Greetings and welcome, friends. Mr. Waddy here with my math buddies, my geometricians. We are taking a look at similar polygons. We discussed yesterday that polygons, right? We've discussed their congruence for chapters now, but it turns out for similarity, there are some traits that are consistent. The angles, for instance, are always going to be congruent for corresponding angles, and the sides will be proportional to one another. Oh, this one they done tricked us here. I believe DG is going to correspond to this SP one. Yeah, they'd be sneaky. All right, so it says find the scale factor. So the scale factor K is the ratio of any two corresponding sides where I take the new compared to the old. So I'll just do the, 1/3 is the scale factor. All of the sides are then going to be 1/3, so 9 divided by 3 is 3, 12 divided by 3 is 4, 6 divided by 3 is 2. All right, it says then list all pairs of congruent angles. So angle G, actually, let's do this the easy way. There's a rotation that took place on this as well. Yeah. This one actually is shaped very much like the sand crawler from the Star Wars movies on the desert planet of Tatooine, piloted by the Jawas. There we go. I almost lost it. Whew! All right. Anyways, K is equal to 1/3. The easy way to do this next part, yeah, I could compare, right, the corresponding angles and say they're congruent. But since they actually gave me the similarity names here, I can just say D is to P, E is to Q, F is to R, etc. So angle G is congruent to, nope, I just said I was going to do something and then I didn't do it. Angle D is congruent to angle P. All right, angle E is congruent to angle Q. Angle F is congruent to angle R. And angle G is congruent to angle S. So congruence is maintained for the angles, while the ratios of the corresponding sides, those ratios are consistent, although the sides themselves are not going to have equal measures. So if I wanted to use the naming conventions here, I could say that, I guess I'll do it in the same ratio as the scale factor, new over old. So PQ, the first two letters, the ratio of PQ to DE is going to equal, sorry, I just used similar there, is going to equal QR to EF. QR to EF is equal to RS over FG is equal to last first over last first. This is where I can find the last one. So SP over GD. And if I notice those, let's actually check one. PQ is right here. I claimed is similar to DE. Yeah, it seems like that lined up. This is my own notation. Instead of using tick marks, using like little similarity symbols, right? So I could say that SR and GF, double similarity. If you're looking for a notation that's completely street math and informal, I'm cool if you start using that for your own notation's sake. The polygons are similar. Find the value of X. Okay, so X corresponds to this here by the looks of it. So I'm going to say X is to 22 as, and then I can compare any two other corresponding sides. I guess little over little would be helpful. 6 over 12. So notice that by row, I have X and 6. So I have got little shape over little shape. By this row, this is big and big. By column, I've got, what's this? Second largest side and second largest side. And then this column is smallest side and smallest side. So when you set up a proportion, there's like a whole bunch of different ways you can do it. But there should be similarity for each column and row. When you have that set up. It's not a bad idea to reduce this fraction. 6 goes into 6 once and into 12 twice. And then cross multiplication. If you want something that works every time, you can cross multiply. 2x will equal 22. Or whenever the variable's in the numerator, I sometimes just solve this algebraically. So I'd multiply both sides by 22, 22. And so I will end up getting x equals 22 divided by 2 is 11 times 1 is still 11. All right. I'm over-explaining that a little bit, but all right, it says these triangles are similar. Identify the type of segment shown in blue. Ooh. What type of segment is that? It connects a midpoint. Well, if it's perpendicular to the opposite side as the vertex, it would be an altitude. I believe these are medians. All right. Yeah, those special segments, there was a lot. It turns out if two triangles or polygons are similar, not only are their corresponding sides proportional, but all other linear dimensions will be proportional as well. So I could set up a proportion. I could say y minus 1 over 16, right? This median over median should equal this side over this side, equals y over 18. All right. Jordan's absorbing this. This is great. I'm going to cross multiply here. So I'll have 18 times y minus 1 is equal to 16y. Let's do some distributing. Beep, beep. And then it's just algebra. Good old times with the algebra. 16y. Subtract 18y from both sides is what I would do. You guys are seeing it. You see this a mile away. Negative 18 equals negative 2e, and then divide both sides by negative 2. Now, did they want to just find the value of y, or did they want the value of these segments? Y equals positive 9. Yeah, find the value of the variable. Dunsies. Yep. I just recorded for the internet me saying dunsies. So, all right, question 21. All right, so I just said a moment ago, if two polygons are similar, all of their linear dimensions will be proportional to the scale factor. Now, area behaves differently, okay? It turns out the areas will have a ratio of the square of the scale factor because their units are squared compared to the original. So the area of one polygon is given, find the area of the other polygon. So this area over 100 is going to be the square of the ratio of any of their linear dimensions. Let's see, I did little over big for area, so I'll do little over big for linear dimensions here. So a over 100 is equal to 1/5, all squared. A over hundo is equal to 1/25. Multiply both sides by 100. Meh. And I get a is equal to 4. And notice that, wait a minute. Wow. This area is equal to 4 inches squared? Yeah, so I could fit 5 of these across, right? Yeah, it's 4 by 1. Yeah, so I could fit a whole lot of these in here. How many could I fit in here? 25 of them, yeah. That's crazy. Crazy. All right, oh yeah, I get this one. Okay, decide whether the red and blue polygons are similar. Yeah, I realize you guys didn't have red and blue on your black and white paper, and even on mine, being inverted, my reds and blues got inverted to light blue and orange. Decide whether or not these are similar. Okay. Wow. Let's see what I know here. So these are congruent, these are congruent, these are congruent to each other, but not the 3s. Actually, I guess I'll label these with double marks. So if this is a 45, 45, 90 right triangle, we don't know all of our right triangle trig, but this is an isosceles triangle. These base angles are going to be congruent. These triangles are all congruent to each other. What would my reasoning be on that? Angle, side would work. Yeah, I think angle, side is the best bet. Also, yeah, these would have been 90. These would have been 90. If this is 3 and this is 3, these two triangles are going to be similar by side, side, side. These 3 triangles are similar by side, angle, side. This is going to be 3 as well. All of their corresponding angles. Oh, because these are isosceles right, then these angles are actually going to be congruent. These are all actually 45, 45, 90 triangles. All of them. Okay? And then actually today, we'll have means of proving triangles similar. Now, in this triangle, even though I don't yet know this dimension, you probably could figure it out if you've been in middle school. I know that this side and this side and this side are congruent. Why is that? CPCTC, that's right. Once I already knew the triangles are congruent, all of their corresponding parts are congruent. I know that this, let's see, whatever this side over 3, or I guess I could say it the other way around, 3 over that is going to end up being a scale factor. Yeah, these are going to end up being similar to each other. They actually didn't ask for much of an explanation here, but we'll have some more skills to more accurately and aptly do that today. I think we're going to leave it at that. Thanks for watching, Internet friends. Bye-bye.